So thank you everyone for joining me today on this out in Oregon lovely Friday morning still for our daily Design Innovation Month tip and trick webcast. My name is Chris Dubuque, located out in our Portland, Oregon office. And today I'm going to talk a little bit about multi-body parts. So let's go ahead and talk a little bit about some multi-body part modeling tips. This is one of those ideas that might be a little bit out there. I wasn't really sure on how much traction I would get with this particular idea, but it looks like it turned out pretty well. So what are we going to talk about here? Well, first off, we're going to go over multi-body parts. What are they? Why would you want to use them? Talk a little bit about some of the multi-body commands. Go through a couple of examples. I only have 30 minutes or so here, so try to keep it as brief as possible. How to use them effectively in drawings, or at least what I consider effectively in drawings, and a couple of extras that always seem to come across right towards the end. Now, really what I want to talk about in this presentation aren't the obvious situations of multi-bodied parts. I consider the obvious multi-body parts weldments. Of course, they're multi-body parts. Weldments are purpose-built to take advantage of multi-body part modeling, which is simply a part model with more than one solid body in it. Pretty simple definition. So I am not going to go into weldments. We had a presentation on that. Nor am I going to really get into mold design, but it is also dedicated SOLIDWORKS functionality for, or leveraging, I should say, multi-body parts. Nor will I talk about surface modeling. Now, I kept the same screen up here because, in my experience, any mold design function in SOLIDWORKS requires pretty significant surface modeling as well. So these three, multi-body, weldments, mold design, surface models, that's not what I'm going to talk about. I'm going to talk about a really simple model. Up on the screen, these are some landing skids to my radio-controlled helicopter. Maybe scratching your head, why would I ever think about using multi-body parts for something like this? And that's kind of what I want to talk about. These commands can be useful for just about anything we do in SOLIDWORKS. They don't always have to be used in only this case or only that case. So my attitude towards this is really anything can be a multi-body part. It's just another set of tools that we have inside of the software to help us get our job done, help us complete that design. So we've kind of gone over what are they here, basically. Now I want to talk about why I use them. But granted, these are just some examples here. So why do we want to use them? Well, in one example of that, it's just one file to manage. So instead of building a traditional assembly and you've got all these assembly files to deal with, it's one part. Now on the flip side of that, kind of a big downside of multi-body parts is it's also just one file to manage. So you don't have the true benefits of an assembly. Now there are commands to take a multi-bodied part, save all the bodies out to individual part files on the drive, combine them together to a traditional assembly. So that can work as well. I like to use them, or I kind of think of these multi-body techniques as I jokingly call them get-out-of-jail-free cards. Sometimes they are modeling techniques that you're definitely not going to start up SOLIDWORKS on a Friday morning and I'm going to use multi-body techniques today. But maybe you run into a situation where using traditional features, it's just way too many steps, or the geometry is kind of odd. I like to use them for importing or modifying imported geometry. A really cool way to leverage multi-body techniques is what we call local operations. An applied feature such as a shell or fillets, for example, they can only be applied to one solid body. They cannot propagate from body A to body B to body C. So sometimes slice a part up, put in a shell, combine it back together is maybe a little bit more straightforward than completely adjusting the feature manager tree in the order of the history or the order of the model and things like that. And really, it all comes down to just alternative ways to capture design intent. That's what I want to talk about here. Maybe just think about modeling problems, design problems, just a little bit differently. And I'm sure there are many other ways to leverage multi-bodied parts that I really can't think of, or just don't have the time to talk about here. So some of these commands that we like to use, or at least I like to use, commands that I find useful. So merge result. This is really it, if you want to call it that, when it comes to multi-bodied modeling. You'll see it in any type of boss operation. I put down the ones that I use more than any: extrudes, lofts, sweeps. So we're adding the solid, and it's just a simple check box. If it's merged, SOLIDWORKS will join the bodies together, or the feature to the existing body. If you unselect that, it becomes a multi-body part. Now, a couple things with this checkbox. I always say keep an eye on this. And because SOLIDWORKS wants to merge that, always wants to merge the bodies. A little tip, even if you're not using weldments and you're not using structural members, add a weldment feature. That'll force the software to deselect that merge result all the time. Another command that I find very, very useful in all sorts of modeling scenarios is the split command. And that will take a single body, essentially slice it up or split it into a multi-bodied part. You can use sketches, planes, surface bodies, faces on the model, any combination of those. So that'll take a single body, slice it into a multi-body. Now the save bodies command, another very, very useful command. Property Manager is pretty big, so I had to split it to show it on the screen there. But this can also be built into that split command on the previous slide. So instead of just splitting the bodies out, you can then save the resulting bodies to separate files on the drive. You can also get to it by right-clicking on the bodies folder. We'll see that in just a minute or two. And the cool thing about the split command is it can take and combine all of those individual bodies automatically into an assembly. Now, it does not add assembly mates. It just positions the new components exactly where their bodies are positioned in the original solid body. But it is very, very fast to take a single body part, slice it up to a multi-body part, save the bodies out, and then combine it into an assembly. That does yield many, many files to keep track of. All those files, you want to be very cautious of manipulating and changing, and definitely don't delete them. But the capabilities are there. Now the combine command is kind of like the reverse of the split. One of those old school Boolean operations that I learned back in AutoCAD 12 days of solid modeling. They can still be very, very useful. Add, subtract, common, or the union command, as you may be aware of it. I use this quite a bit just because sometimes it's easier to intersect a couple bodies, or common, it used to be called intersect. Sorry about that. There's a standalone intersect command inside of SOLIDWORKS, and it's been that way for a couple of years, but old habits die hard. But use that common or union option to generate the model geometry as opposed to individually creating the faces, edges, vertices, things like that. So let's get into some examples here. So I mentioned I like to use, again, typically use these for quote-unquote difficult modeling situations, and I showed the screen a little bit earlier. And this may not be what you would think about as a difficult model. And it's really not that hard in the grand scheme of things. But it does have a few very interesting aspects to it. I've taken these two profile views because we've got this kind of tapered, width for the legs so the aircraft doesn't fall over. But then notice the top of these arms or these legs are wider than they are at the bottom. So that simple little variation in the thickness there from top to bottom is what can kind of make this a little bit tricky. It's not as straightforward as just one click to get it done. So I thought about this. If you're going to model a part like this, traditional features, meaning trying not to use multi-body techniques, requires multiple sketches. I needed a couple of projected curves. Therefore, I could do a sweep with guide curves. And depending on the result of all of that, if it's good enough, then I would need to repeat all of those steps to take the the leg in the back, for example, and then model the leg in the front, or vice versa. So it's definitely a fairly involved operation. Whereas, a multi-body approach really comes down to two simple extruded bosses leveraging that combine command, and then a move copy body, and it's done. So I'm just using it as an example of, evaluate the geometry one needs to create, and if these work, fantastic. Maybe it's just a different way of going about doing things. So let's look at this model. Here's the part that I created inside of SOLIDWORKS. Again, trying not to use any multi-body techniques, and for me it's kind of hard. That's why I wanted to talk about this. I just seem to be leveraging them all the time. But if we roll back here, here's the first sweep. We can see both models. You'll see they will share the same common sketch 1, that side profile that I'm looking to capture, as well as they will both capture this same sketch number 2 for the width of the landing gear. Now, in order to adequately control the geometry, again, I needed a guide curve in the front, extra sketches using convert entities, the guide curve in the back, a sketch with the appropriate sweep profiles and dimensions so it doesn't become underdefined and it doesn't, quote unquote, do anything odd on me. And then finally, a sweep with guide curves. And it actually comes out decent. And the reason I say decent is these faces don't actually give me the design intent I'm looking for, and that is to have them planar. And they actually are not planar. There's a bit of twist to this feature. Just a little tip that I like to use to quick check to see if a face is planar. Click on it. If the Insert Sketch button is in this bottom set of commands, it's a planar face. In this case, it's not planar. We can further evaluate that if necessary with a right-click curvature, and we can see, a little bit hard to see up on the screen, but even though it's almost planar, we're out to -5, -6. It's SOLIDWORKS. If it's not perfectly 0, it's not planar. So it's close, but it's not exactly what I'm looking for. But depending on the scenario, it may be good enough. This is that situation where we evaluate it, and then we build the second extruded boss, or excuse me, extruded boss is the little pipe right there, and the same sketches, projected curves, profile, sweep with guide curves, and then complete the model. Kind of a silly example, but again, just something else to think about. Now, if we look at a different way of building that part, leveraging multi-body techniques, we can see that it starts with the same layout. In this case, I've just renamed a couple of features. But to really generate this part, it's quite simple. So I've got an open profile sketch, simply extrude the boss there, kind of eyeball about how far to go. This is that merge result that, in this case, we absolutely want to deselect. Let me jump to the front view, turn on the thin feature options, and I'm going to independently set these to 2 directions. I like this enhancement that we've got recently in SOLIDWORKS where we can have a couple of different independent directions in thin features, and we can say OK. So now I just have this kind of wall. I could then easily take this next feature right here. Again, I captured that in sketch number 5, just a new sketch, convert entities, nothing overly interesting there. Through all, and notice again that's automatically selected. SOLIDWORKS loves to merge your solid body, so keep an eye on that. Thankfully, if you accidentally merge, you can always edit the feature and deselect that merge. It's not the end of the world. Say OK. And now I have these 2 very simple solid bodies that essentially interfere with one another. So we can go to Insert Features and Combine. Select the 2 bodies we're interested in, switch it over to Common. You can always show the preview if you want, but in this case, I know it's going to work. We'll say OK. And there's the actual geometry that I really wanted. And very simply, I can select on that face. The sketch command is there, so the surfaces are planar, which that was the desired design intent. Now, I'm not going to repeat the process of creating extruded bosses or anything. I'm going to simply take this body and move it. Now, the cool thing about a lot of the commands in SOLIDWORKS, all the patterns, they support bodies just like features, just like faces. So I could use those if I wanted to. But I want to talk about as many of the, I guess I would say, dedicated multi-body commands as I can. And one that I find myself using constantly is move copy body. So we'll select it. I'm going to switch it over to the environment that essentially gives us mates in the part. We'll look at that in a couple of minutes. And I'll switch it over to the simple XYZ translation or delta XYZ rotations. So there's a nice option to copy it, and you can increase the number of instances or the number of copies. And you can simply drag the body around and simply deselect that copy, turns it into a move operation. Nice thing about this is it really makes no difference on how that body was created. The features are still intact. The tree is still intact. I can just take this body and move it around. Now, I do need to precisely locate this body right there, and I don't want to do any measurements, although I could key in that exact value. But there's a very much, in my experience, overlooked way to do this inside of the move copy body command, and that is to simply select a vertex on the body we want to move, and then a sketch point or a vertex on the destination. So it's a very simple, I'll just say from to movement. There's no dimensions to key in, and now I have a copied body that's linked to my layout sketch. So pretty easy way to do it. At this point, we could go through the process of leveraging that combine operation. An additional way to get to the combine operation is simply to expand that bodies folder. There we can see in the feature manager tree our 3 solid bodies. We'll just shift select those, right click, and there is the combine operation, and we will add them together. Pretty easy way to do it. No guide curves, nothing to really worry about. Last but not least, let's leverage good old mirror. Choose a common face. I don't want the features to mirror, so we'll right click and deselect that. Come down to bodies to mirror, say OK, and the skids are done, minus a couple of fillets. So again, not a very difficult model in the grand scheme of things, not really difficult in any scheme of things, just a different way to tackle these modeling situations is really what I want to talk about. Now, another example, imported geometry. As we all know, there's no features to edit. Now we can delete some faces and things of that nature, but if you really need to make some changes, it's not the easiest thing to do. So we need to get creative. And what does that really mean? Well, typically we need to remodel some features. But in this case, we need to change it from the model on the left. We need to take this little lug, rotate it 180, and move it away from the center of the part. You may recognize this model if you've gone through some of our classes, but I like it. It's an interesting example. So I like to say multi-body techniques to the rescue. Let's jump back into SOLIDWORKS real quick. So we've got our multi-bodied part. Before we do anything else, the most important thing we all need to do with any multi-bodied part is make sure that we run import diagnostics. You don't want to have a failed face edge vertex cause some really serious problems for you down the road. So before you create any native SOLIDWORKS feature, please run import diagnostics. It'll help you out, that's for sure. So everything's good, no faulty faces or gaps. We're ready to add some native SOLIDWORKS features. So I'm going to make an offset to the front plane. Way that I like to do it is just hold down the control key, drag the plane. Just a shortcut built in the software. Maybe you know it, maybe you don't. Just an easy way to get into the reference plane command. I'm going to use this kind of natural seam in the model. Click that vertex, and that will locate the plane. So parallel to the front plane, passing through the vertex on the model. Right-click the mouse to say OK. And now plane number 1 can be used to split this part. So insert features split. Select the plane. Cut the part. Hit the little scissors icon. Now, you might be wondering, why is there a scissors icon? What did these little check boxes represent? Well, I could have multiple intersecting planes that could slice this into 2 bodies or 4 bodies or 8 bodies or 16 bodies or whatever the case is. You do need to cut the part so the software can calculate all the potential resulting bodies, but the actual selection boxes here in the resulting bodies window, that's what truly cuts it. So even if there were a possibility of creating 16 bodies, I could choose it in a way that only creates 6 bodies, for example, or 8 bodies or something like that. Now, if we want to further save these bodies out to the drive, just double-click in that field right there, and there you can see the window pop up. Or you can select the tags in the graphics window. So that's that, I'll say, integrated save bodies functionality. I'm not going to use that here, so we'll say OK, and hide that plane. And we can see that in the bodies folder, they are in fact 2 solid bodies. So here's another little tip I like to share. Tab to hide, hides bodies, Shift Tab, hover your mouse over where those bodies are, Shift Tab shows them. It works in assemblies as well. Kind of one of my favorites to leverage. And we'll go back to Move Copy Bodies, but now I'm going to use the shortcut toolbar. This is exactly how I have my shortcut toolbar set up all the time in SOLIDWORKS. You can see, here's my multi-body commands. Again, I tend to use them quite a bit, so I'll leverage Move Copy. And now we'll switch it over to the constraints, or essentially assembly mates, but in a part model. Now, these are only used for positioning. They do not transfer any motion like we're all familiar with in the assembly environment. But what I can do is select the body I want to move, and let's take the face on the top of that lug and mate it up to the face of the bottom of the part. Now it's upside down, so we do flip the mate alignment, as is fairly typical. It kind of flies around, so we will say add that. Now I'll select this face right there and that face, and we're going to switch it over to a distance mate. So these are familiar mates. They work the exact same way as we should be used to in the assembly space, with the exception of we do need to select the add mate in this environment. And last but not least, select the side face, the model edge, choose coincident. You can see they don't auto-solve like they do in the assembly space, but positionally speaking, they work the same way. So there's that mate. Everything looks good. If we need to edit those mates, we can see the Move Copy Body in the tree and the individual mate features, and you can right-click on them, and somewhere in there is Edit Feature. Nope, Edit the Move Copy Body. I always forget about that. It gets me every time, and there we see the individual mates that we can edit. So kind of like an assembly, but not like an assembly mate. So let's merge it back together. And to do that, we'll just select the face, insert that sketch. I'm going to use my shortcut toolbar again to leverage Convert Entities and use my shortcut toolbar. I'm just hitting the letter S. Great enhancement that they put in SOLIDWORKS, well, a really long time ago. But if you haven't used the S key, the shortcut toolbar, I highly recommend looking into it. I've just right-clicked and chosen Customize. You can set up one for parts, assemblies, drawings, sketches. Yes, I know it's kind of off topic, and this really has nothing to do with multi-body parts, but big fan of the shortcut toolbars inside of SOLIDWORKS. So now we'll go back to Extruded Boss, choose our end conditions. We do have an option for up to body. Click the body, and we will make sure that that merge result is enabled, and that way everything is merged together. Down here at the bottom, something that very commonly is forgotten about or just missed with multi-bodied modeling is the feature scope. And this controls how this feature, a boss extrude, interacts with various bodies in the model. If a feature intersects a body, the auto select is on, but you can always deselect it and choose this body versus that body versus another body, or 4 out of the 10 bodies for this feature to interact with. It can be quite useful to leverage that feature scope down at the bottom. Auto select, I'll keep it on. Green checkbox OK. And our multi-bodied part is now a single-bodied part. So again, just a quick example of using some multi-body techniques for imported geometry. And the last example, I call it the classic example from Essentials. This part has been around forever in my experience. And the trick to it is we only want to shell the base. And the base is just simply this piece of geometry right there. So the idea in SOLIDWORKS Essentials is to teach everyone about the feature manager tree and parent-child relationships and the cool ability to reorder features in the tree. And by showing it this way, I'm not in any way, shape, or form saying that that's not valuable. It absolutely is valuable, and in many cases I would recommend that is the best way to go about doing things. But I'm sure you've seen it. I know I have. Sometimes reordering your features in the tree can be a little bit difficult, or they can cause downstream features to fail, or there's all kinds of reasons why that can be a little bit cumbersome. So this is, again, just a different way of getting the same end result design intent. So here's the model. The shell's at the bottom. Yes, we could drag it up the tree and deal with the parent-child relationships, but it's 11:27 my time, and I have a design review at 11:28, so I need to get this change done right this second. So just an alternative method, the shortcut key to the split command. In this case, we'll use a face to create that cut the part, hit the little scissors to grab all the bodies, green checkbox OK. And I've split it accidentally. I split it before the shell. That's okay. Thankfully, we can take these features and leverage what we did learn in Essentials to reorder the feature manager tree. We reorder the split before the shell, and because the shell can only interact with one solid body, that's all there is to it. And it's 11:28, so even with my mistake, I get the part off to my manager and I make my design review. So just a different way of looking at these modeling situations. To complete it a little bit further, let's select the two features in the tree, right-click and combine. We'll use the add to say OK. And just like from previous versions, yes, those tubes are out of order. So let's get those lower holes. And even though it was a multi-body part, we can simply still drag and drop, leverage that flexibility in our feature manager tree, and get that design change exactly where we need to. So we looked at a couple of examples. Let me talk a little bit about using these in drawings. Now, multi-body parts in drawings, honestly, well, they're almost exactly like regular parts. But a couple of questions, what if you need a bill of materials? Well, maybe you should make it a true assembly, but there's another way to get there. And what about managing one of the individual bodies? That's the most questions that I get about any type of multi-body part. So wrapping up here, let's jump back into SOLIDWORKS, and I'll load up this little table. Just a little context, this is something I modeled up, well, back when my children were very, very little. Wanted a project with now my oldest daughter, still my oldest daughter. Just build a little picnic table for the deck. Now, if we take a look at the feature manager tree, I did not use weldments, although that would have made a lot of sense. I just did very simple multi-bodied extruded bosses, patterns, things like that. And as we'll see here, I do have 18 individual solid bodies in the solid bodies folder, but we can open up the drawing. Again, they work exactly like parts and single body parts assemblies. It's all the same. We can drag and drop the views from the view palette. We can create our isometric views, hold down the control key to break that alignment. We can place it over there. Again, all the same rules apply. Just a couple of things that I want to touch on that's a little bit unique with a multi-bodied part is, see this happen quite a bit, and I need a bill of materials. Well, don't forget, even though it looks like an assembly, it is still a part. So, not a very exciting bill of materials. So what do you do at this point? Well, one thing that we can do is if we switch back over to the part modeling environment is to make it a weldment. Even if we don't use our structural member commands and trims and all of that, we can still turn it into a weldment. So we can go to Insert Weldments and add that weldment feature. What's really nice about this is notice that bodies folder now turned into a cut list. And SOLIDWORKS automatically categorized all the extruded boss bodies into folders as if I created them with structural members. Now, I will admit I do not have the benefit of all the nice automatic properties that we get from our weldment profiles into our structural members, but it's not too difficult to go in and add maybe a descriptive property here. Not super exciting for my descriptions, but we could go ahead and add some information there. There we can see highlighted in blue the frames for the legs, or the supports for the legs. So we'll go ahead and put that information in there, and here's the legs. So I'll skip cut list item 3 here. So just a different way of looking at it. And save it, Control-Tab over to the drawing. And now, when we select one of these views, our isometric views, the tables drop down, it now has a weldment cut list. So just a little workaround that can sometimes be useful in those cases without going through the process of making it a true assembly or anything like that. And we can also select that isometric view and put in our auto balloons as well. So sometimes can make it much easier to work with. And the last thing I want to talk about in this example, as we're just about ready to wrap up here, is what if we need to select one body to make a drawing view of? We need to detail, for example, one of these angled legs. Well, it's actually pretty easy to do, like a lot of things in SOLIDWORKS, if you know exactly where to click the mouse. So I'm creating a view layout, or excuse me, a new model view, selecting the open part file, and this easily overlooked button right here, this is the key to make all of this work. It's select bodies. And what will happen when I click on that is it will go back over to the modeling environment, and I could select whichever body I would like to use, in this case, that leg right there. Green checkbox, OK. And let's turn on the preview. I think that one will work right there. Click the mouse and place it. Now, essentially, the remaining bodies in this view are just hidden. So the orientation may not be exactly how I want it. I really would like to rotate this so that edge that I'm selecting, or maybe the upper edge, whichever one, it's horizontal. So let's just select that edge. And we'll go to the Tools pull-down menu. I don't see this command used too much either, but Align Drawing View. And the edge that we select, in this case I'll choose that horizontal edge. And this particular edge that's selected, that's going to be pointing down, if you will, to the bottom of the drawing sheet. So if I would like to rotate that 180 degrees, of course I could use the Rotate View command, or I could just select the now upper edge. Again, we'll go to Tools, Align Drawing View Horizontal Edge, and it'll flip it around. Now I can add my standard annotations. I don't have any model items on it, so let's select our just simple smart dimensions, and we'll call out this right here. Don't forget, you can select the endpoint of that vertex to get the quadrant arrows to control your angular dimensions. So I'll pick the vertical arrow, and then I can drag up that 30-degree dimension. So just a quick little overview on some of the things that you can do and better leverage the information in a multi-bodied part for your drawings. All right, last but not least, a couple of extras. So exploded views. Yes, you can create an exploded view in a multi-bodied part the exact same way that you can in an assembly. You cannot animate an exploded view, though, nor can you create a video of that animation of an exploded view for a multi-bodied part like you can for an assembly. But you can do it. The other thing, interference detection. So you can run interference detection if you're using SOLIDWORKS 2019. Older versions of the software, what's the trick we always did? We'd take our multi-bodied part, temporarily put it into an assembly, run an interference check, fix it, kind of go through that cycle. Now you don't need to. I will say interference detection, it's exactly where you would expect it to be in SOLIDWORKS, even though it's a multi-bodied part. It's on the Evaluate tab, interference detection, and it works the same way as if it is an assembly. So in this case, we could go ahead, fix our weldment model if we need to. And this does happen to be a traditional weldment with structural members. So on the Evaluate tab, interference detection, and just like a regular assembly, you can go ahead and exploded view. Get you into the assembly loader. Works very, very much the same way as an assembly exploded view. And the feature scope, I mentioned that. Don't forget about the feature scope whenever you're in any type of extruded boss, extruded cut type operation to control which body that feature interacts with. And that really brings us to the end of our presentation. We've covered everything from what they are, maybe why we use them in modeling commands. Went through a couple of the commands, a few examples, how to extract those single bodies and detail them out in a drawing, and then just a couple of extras at the end. So with all of that said, I appreciate the attendance very much. Thank you so much for spending about 35 minutes with me this afternoon. If there are any questions, there's my email address. Please write it down. Please send them in to me. I'm always open for questions and answers. If you guys have any ideas or topics you would like to see in future webcasts, also send them in as well. And don't forget to check out our website, cati.com, for other Design Innovation Month webcasts that we have every single day in the month of October. So with all of that said, thank you very much. If you have any questions, fire them in through the chat. And if not, have a great day, a great weekend, and hopefully I'll see you on Monday when we go through our next webcast. So thank you much, everyone. Have a great one.